Now we're going to incorporate both the addition and multiplication principles into helping us solve some linear equations. Let's begin. Here we have the equation 9x plus 2 is equal to 38. What we'd like to do is solve for x. Remember, that means getting x on one side of the equation all by itself, or in other words, isolating that x. Now we see that right here, 9x plus 2, we have a 2 that we'd like to get rid of. Since we're adding 2 there, one way to get rid of a plus 2 is to subtract 2. But we know by this time that whatever we do to one side of the equation, we're going to do to the other. So we subtract 2 from the left-hand side, we're going to subtract 2 from the right-hand side. Now we're going to bring down the 9x. We have plus 2 minus 2, which is 0, equals 38 minus 2 gives us 36. Now, sometimes students get confused because they don't know whether to add, subtract, multiply, or divide, or which operation to choose first when solving these linear equations. Let me give you a little hint. The first step here is we wanted to isolate the 9x because that's the term that has the variable incorporated into it. So in order to isolate the 9x, we have to get rid of whatever numbers with the 9x. In this case, that happens to be the plus 2. So because we have a positive 2 there, the way we get rid of that positive 2 is to subtract the 2 as we did there. Now, what we have left is this 9x equals 36. Now this is 9 times x. The way we undo multiplication is to do division. So what I'm going to do is I'm going to choose to divide both sides by 9 to eliminate the 9. What I get as a result is x equals to 36 divided by 9, and I get 4. Now if you're unsure of yourself at the beginning, you can always take your solution here, substitute it back into the original equation and check. 9 times 4, 36. 36 plus 2, 38. And the check works. So we can be assured that x is equal to 4 in that first equation. Let's look at another equation here. We have 13x equals 2x minus 66. Again, our goal is to solve for x or isolate x on either side of the equal sign. I see right now to begin with I've got x on both sides of the equal sign. So what I'm going to do is get it on one side. Now I see that I have 13x and 2x. Since 13 is bigger than 2, what I'm going to do is subtract the 2x from both sides. So subtracting 2x from both sides of my equation. When I do, I have 13x minus 2x, which is 11x, equals 2x minus 2x, that's 0, equals the negative 66 there. So far, so good? Now we're almost there. We've got 11x here. All we need to do is isolate that x. So what we're going to do, since it's 11 times x again, we know that division undoes or undoes, or whatever you want to say, multiplication. So we'll divide both sides by 11. When we do, we see that the 11's divide out, and we're left with x equals negative 66 divided by positive 11 is negative 6. Now again, the nice thing about these problems is you can always take the value for x, substitute it back into the original equation, and just check to make sure that your solution makes sense, or in other words, you get a true statement as your original equation. Now those were some basic problems. I think we're ready to try a few more, a little bit more challenging problems. But again, we're going to keep incorporating this multiplication and addition principle. So let's look at our next example. We're going to try this one, 2x squared minus 6x plus 3 equals negative 4x minus 7 plus 2x squared. Now, you may feel overwhelmed by looking at such a long problem. We're going to take it step by step, and you'll see that it's just as easy as those shorter ones. Now, the first thing we're going to do is look at each side and see if there's anything that we can combine. Are there like terms anywhere? No? No. Now let's try to get x on the same side of the equation. In this one I see something a bit different. I see x to the second power. In fact, I see 2x to the second power on the left-hand side. Fortunately for us, I've got a 2x squared on the right-hand side of the equation as well. So what I'm going to do to eliminate this problem is I'm going to subtract 2x squared from both sides of my equation. Once I do, that will eliminate the 2x squared term. This gives me 0. I'm left here with negative 6x plus 3 equals negative 4x minus 7. All right, now this looks a little easier, doesn't it? I've got negative 6x and negative 4x. I've got to either add 6x to both sides or add 4x to both sides, because what I want to do is get all the x's on one side of the equation so that I can solve for x. Well, it's your choice at this point. You can either add 6x or 4x to both sides. I'm going to choose in this case to add 6x to both sides. Now you may be asking why. The reason I choose that is because I know that if I add 6x to both sides of my equation, my x term will be positive, and I just like having a positive x there. So this gives me 0. I end up with 3 equals negative 4x, and positive 6x is 2x, and I subtract 7. Now we're almost there. I see I have the 2x term. I finally have all the x's on one side of the equation. I need to get rid of that negative 7. To get rid of a negative 7, I'm going to add 7. But whatever I do to one side of the equation, I've got to do it to the other. So I end up here with 10 equals 2x. Notice 0 and then 10 on the left-hand side. Now, I'm almost there. I see that I have 2 times x. To undo multiplication, I'm going to do division, but whatever I do to one side of the equation, I do to the other. So 10 divided by 2 is 5. These 2's divide out, leaving me the x. So I conclude that x is equal to 5. Again, you can always check to make sure you're correct by taking the x equals 5, substituting it back in this original equation to make sure that x is equal to 5. Now, let's try one last example. In this last example, we're going to incorporate yet one more principle that we used before, and that is the distributive property. Do you remember that? We'll look at this problem. 5 times 2z minus 1 plus 7 is equal to 7z minus 4 times z plus 3. All right, kind of a long equation again, but I think we're ready to handle it. Now, when I look at this equation, the first thing I notice is I have parentheses involved. Parentheses here and parentheses there. Now, I know from my experience that when I see a number outside of those parentheses, I want to incorporate the distributive property. So I'm going to do that now. 5 times 2z is 10z. 5 times negative 1 is negative 5. Plus 7 equals 7z. And again, I'm going to use my distributive property by multiplying. Now be careful here because that's a negative 4 that we're going to distribute, which gives me negative 4z minus 12. It's looking a little better. Now let's look at each side and see if there are some like terms that we can combine. On the left-hand side, I have 10z. And notice I have a negative 5 plus 7. Negative 5 plus 7, positive 2. Equals, on the right-hand side, notice I have 7z minus 4z, which we know is 3z. And then I have a negative 12. So what did I do from that step? The second step here to the third is I added these two together to get my positive 2. I added these two together, the 7z minus 4z, to get the 3z there. That's all we did. Now that that's taken care of, our next job is to get z on one side of the equation. Notice I have two terms containing the z's. I've got 10z on this left-hand side. I've got 3z on the right-hand side. So in order to get all the z's on one side, I'm going to take and subtract this smaller 3z from both sides of the equation. Again, whatever I do to one side of the equation, I do it to the other. 10z minus 3z 7z plus 2 is equal to 3z minus 3z. That gives me my 0. And then I bring down my negative 12. We're almost there. Here's my 7z, my term that contains my variable. I still need to isolate it. That's my job in solving these equations. I still have a plus 2 by it. To get rid of that positive 2, I'm going to subtract 2. But I remember that whenever I do to one side of the equation, I do it to the other. So I have 7z here equals 2 and negative 2. That's 0. Negative 12 and negative 2. That gives me negative 14. We're almost there. Here we go. We have 7z equals negative 14. The last step in solving this equation is to get rid of that 7. The 7z means 7 times 7. To undo multiplication, I'm going to do division. But if I divide this left-hand side by 7, I'm certainly going to divide the right-hand side by 7. So 7 divides out by 7. That leaves me as z equals negative 14 divided by positive 7 gives me a negative 2. So again, if you'd like to check to make sure you didn't make a mistake, take the negative 2, substitute it back in for z in the original equation, make sure you get a true statement, and that'll assure you that you did everything correctly. So let me just go through the procedure because I know that there are many steps. The first step is if you see parentheses, get rid of the parentheses by applying the distributive property. Secondly, collect like terms on each side of the equation if necessary. The next step, we want to get the variable term on either side of the equation as we did here. The next step, we want to isolate the term that contains the variable as we did here. And finally, the very last step is we want to isolate the variable itself by undoing the multiplication with the division principle. Follow these steps. Be very careful as you work, being cautious of your signs and products because, again, there's many room for error, and any one error in sign or multiplication will give you the wrong answer. So be very careful as you work and have fun.